Three, two, one. Let's begin. Welcome to May and Thomas class. Today, I want to introduce the conception of limits and continuity in calculus to you guys. There is no denying that the things of limits and continuity is important in our daily life. So, I will conduct my presentation through three parts: introduction of conception, application in mathematics, and application in real world. Firstly, let's see the definition of limit. This one, we can read it as the limit of f of x as x approaches c equals to f. A function f(x) has a limit as x approaches c if and only if the right hand and the left hand limits at c exist and are equal. If we cannot find a limit directly, we may be able to find it indirectly with the sandwich theorem. Let's do an exercise about limits. Please calculate the limits in the following function. Oh, sorry. Let's do an exercise about limits. Please calculate the limits in the following function. This one. You know, I like drawing, like my butterfly. Can you do it? No, that's the answer. Okay, I can show you the answer. Certainly, the concept of limits is not only in mathematics, but also in our daily life. For example, when we are driving a car, the meter will display the velocity of our car. The velocity represented in the car is instantaneous velocity, the adjective. Also, the concept of limits is closely related to the idea of continuity. A function is continuous on an interval if and only if it's continuous at every point of the interval. Let's do some exercise about continuity. Find a value of a so that the function is continuous. That's the answer. Like limits, continuity also existed in our daily life. Take the appearance of human being as an example. We cannot tell the difference of a person in 1 minute. However, there are huge differences of one person from infantile time to old time, and the biology tells us the growth of a human is continuous. Also, people may claim that the river is continuous. This claim implies that continuity exists in running river. This video is about the concept of limits and continuity. Thanks for you listening.
Limits are the most fundamental ingredients of calculus. To develop calculus for functions of one variable, we need to make sense of concept of limits, which we needed to understand the continuous functions and to define the derivative limits involving the functions of two variables can be considered more difficult to deal with. Fortunately, most of the functions we encountered is fairly easy to understand. In other words, limits is the y-value that a function pretty much approaches. Well, that is a really informal way to think about it. For the continuous, in simple words, if you can draw a function without lifting up your pen or pencil, the function is continuous. In mathematical analysis, the maxima and the minima, the respective plurals of the maximum and minimum of a function, known the collective as the extrema. The plural of the extreme are the largest and the smallest value of the function, either within a given range, the local or relative extrema, or on the entire domain of a function, the global or the absolute extrema. Pierre de Fermat was the first mathematician to propose a general technique at quality for finding the maxima and the minima of the function. As defined in set theory, the maximum and the minimum of a set are the greatest and the least element in a set, respectively. Unbounded infinite set, such as a set of real numbers, have no minimum or maximum. So let's solve a problem here. Here's a function. Limit gx equal to 3x approaching to 4. So let's solve this problem. Here, if x approaching to 4 to this function by his left. So here it is. Gx equals to 3. And no, so it's a function approach, it's an x approaching to the function by the right. So here it is. Both of them are approaching are equals to 3 at last. So that's very important to keep in mind. Whenever we are given that a limit exists and the only thing that we knew is that the left and right limits both exist and equal what the limit does. So that's one thing we need to keep in mind. So let's look at our next graph. It is an example of what I mean. This function is out for the f of 1 is well f is 1 clearly if f is approximately 1.5. So we are given what is the limit as x approaches 2 of this function. So if then y value of the function is pretty much approaches to 2. So now the way to analyze this is always look at the right hand limit and the left hand limit. So let's write down the functions. So as you can see from this function here, we look at the x approaching 2 from the left means that we're looking at the x value of 1.99999 on limitless 9, so that the value here is absolutely 2. So we write down here 2, and so look left side limits is 2, then we look at the right side of limit, which is x approaching from the right. As we can see, x value is 2, so we got the y value of 1 here. Now, since the right hand limit doesn't equal to left hand limits, we can get there's no limit in this function. The limit in this function does not exist. So only left hand limits equals to right hand limits. There's a limit in this function.